So thanks a lot, guys, for the introduction and for being here. I know that it's hard after the lunch break, so I will try to be very concise. So it's a quite broad topic, and the idea is just to share some ideas and concepts, and then to have a discussion, if you want, in the stand that we also have next to the coffee machine, where you will find the free beers. So that's an easy way to start conversation regarding this topic. So the idea is to share a bit of those topics. You probably know that data and AI has advanced a lot over the last few years or months, maybe, and we can find those within a lot of products and services, data products, the ones that we have used to get here, the ones that were not from Malaga, where the heck should I go? The recommendation that we got from the train to see a movie where we were commuting towards here, or when I use the weather channel to know that I have to bring an umbrella because it's going to rain. So data and AI is everywhere. The thing is that even though this has advanced a lot, it's still a complex endeavor to do for most organizations for several reasons. Given my background, I do know a lot about this for the PhD, and I know that these kind of products are very intensive in terms of data and computation, and that's still very hard to handle. You will know that based on the conversations and the discussions that are happening here. The other thing is that besides the computation, behind the way you handle the data, you need also to include modern solutions regarding data, analytics, and AI within those products in order to be useful and to actually harness the data. So how do we build those products? What we have learned over these years in Globant is that you need not to fail fast, but to iterate fast. Start with the POCs that we usually tend to skip aside because that's basic stuff in theory. Then transition to a prototype and then an MVP. That is also a term that has been widely used. But when we are talking about a POC, what we actually mean in this context of data is to test some core principles of what we want to build. For instance, and a real example, we have built an application to detect skin lesions for specific diseases, and that works perfectly in the papers, right? And when you have the lighting conditions, you have good cameras, you have 97, 98% of accuracy. But when you go to the hospitals, the mobiles are not that good, the lighting is not that good. And one thing that we haven't checked, and that's a pretty important thing regarding the POC, is that when you take a picture of this, how do you know if this is a leg, an arm, or a torso? Because that's not part of the problem that you have meant to solve. And that's what you will discover in this iteration. There are several solutions. We had to think about where to get images from naked people. The discussion was pretty interesting. We had to narrow that a little bit towards being in a company, a public company. But that's the first iteration. When you have that already in place, you can move towards a prototype. The prototype is you have the principles, you have the sets that you want to develop, and start building and connecting stuff to actually have a product. In this stage, you will find some problems. The good part of the what actually means for this is that you start to gather feedback from real test cases. That is where you discover that you don't have the APIs, you have to also include another middleware because of the access to the data and other things that arise in this iteration. The following iteration, the way we iterate really, really fast in this is to actually move towards an MVP. The MVP is the first iteration of a product, is where you start collecting real data, probably from friends and family for a reduced set of features, but that's with the way you start building this. In this application that I just mentioned regarding the skin lesions, we were using this in a specific hospital with real doctors, and they were providing feedback to us in order to improve the way we operate this. For instance, the skin colors that will affect greatly the boundaries of the lesion, because that's really, really important. And that's something that in the models, we don't tend to tackle at first. But in the real world, we need to do it. And that's what you will discover here. So all pretty, right? But is this really straightforward as it sounds? No, it's not, of course. We will face another set of problems. When we have products, we need to build them, and then we need to run those on top of data platforms. When you start digging into the principles and the features of those products, you will see that there is heterogeneous computing. We tend to have very specialized hardware that could be real hardware or virtualized ones, GPUs, TPUs. We have uniform use of resources. It's not the same way of treating and using the data and the access patterns when you are modeling, when you are training, or when you are working in the inference or services of the different models in AI. That's pretty heavy differences behind that. And finally, that this is something that we also tend to skip is what happens after that when you have to deploy those models, when you have the different versions, when you discover that the data sets that you have been using are not GDPR compliant, and you need to skip that and to have different versions of the libraries, and that maybe you're using an NLP solution or a library that is great, it doesn't work for the Canary Islands because the accent is different, the words that we use are way different. So those things are the principles of we are missing something, and maybe we need a new discipline, a new part of the structure is the machine learning operations part. When we move towards the platform, there is actually the place, you could name it data mesh, data fabrics, lake houses, or whatever you want, but let's use the platform concept as an umbrella. You will also find that you have the versioning, the lineage of the data, the processes, those data sets that we were mentioning regarding the skin lesions, that's private data. You cannot train other algorithms based on that. So the idea is to move forward. Whoa, already finished? Yeah. I skipped the other part. So I will move a little bit towards the end then. So how does this look like? There are three main foundations or principles of machine learning operations, even though this is still an open field. The governance, there is the boring part probably for us, or at least for me, but it's extremely important in terms of the access to the data, the security, how to provide access to that to the different stages of the development. Repeatability, that is extremely important for applications that use and products that use personal data. Extremely important because you need to audit most of those solutions at the end of the day if it's facing the public. And the continuous process, that is what we have learned for software development applied to AI. What's coming down the road, and I'm closing with this, such as we have seen the rise of data platforms very specialized for data products. The same is happening with machine learning operations. There are platforms that are trying to tackle those wide open fields and trying to avoid having data unicorns that are going to be the ones that tackle the governance, the process, and the repeatability. And there is another one that in this world, there is a new, not that new concept, that is the future store that is coming down the road that is going to be part of those platforms. Very similar to a warehouse for data, but for features in models. That should not be structured or not mandatory, but it's what is becoming the most common pattern in the development of data and AI applications. Like I said before, if you want to have a deeper discussion and tell me you're telling nonsense, come to pay us a visit in the stand and we will have some beers. So thank you very much and see you soon in the stand.